Section 4.6, Modeling with Exponential Functions, Part 4. Okay, another Newton's Law of Cooling problem. Again, we just make sure we familiarize ourselves with what variables represent. D is the initial temperature difference, the difference between the object and the surrounding temperature. Ts is the surrounding temperature all by itself. Our formula measures the temperature of the object at time t. K is a constant. K is a constant that depends on the type of object. Let's look at problem 104. The car engine runs at a temperature of 190 degrees Fahrenheit. When the engine is turned off, it cools according to Newton's law of cooling with constant K equals 0.0341, where time is measured in minutes. Find the time needed for the engine to cool to 90 degrees if the surrounding temperature is 60 degrees. Okay, so let's see if we could set up our model. D sub 0 is the temperature difference between the object and its surrounding. Okay, so our engine is the object. The engine temperature initially is 190 degrees. Surrounding temperature is 60 degrees. So D sub 0 would just be 190 minus 60, which would be 130 degrees Fahrenheit. Ts is the surrounding temperature all by itself. That's our 60 degrees. Luckily, we don't have to find K this time. We're given the constant K as 0.0341. 0.0341. Okay, so let's get our model. We have the temperature, and we're looking for time. We want the temperature of the object, which it's going to cool to 90 degrees. So we have 90 is equal to Ts, we said was 60. D sub 0 we said was 130. E to the negative. K, which is 0.0341. And we're looking at solving for T. Okay, so first thing we're going to do is we're going to subtract over that 60. So 90 minus 60 is just going to give us 30. It's 130 e to the negative 0.0341 t. We'll divide both sides by 130, so we get 30 over 130 equals e to the negative 0.0341 t. How do we get rid of e? We get rid of e by natural logging both sides. So we get 30 over 130. We're going to ln that. When I ln e, they cancel out. So we're just left with our exponent. Lastly, all we need to do is divide that over. Okay, we're going to put this all in our calculator. So we have the natural log of 30 divided by 130. I'll take that and divide that by negative 0.0341. And time is in minutes. How long will it take for that engine to cool to 90 degrees Fahrenheit? About 43 minutes. So time is approximately 43.0 minutes. Newton's law of cooling is a very nice formula. It works nicely as long as you take the time to look at what all of your variables represent.